So let us start by understanding what is the need of Apache Spark. So 2 to 3 decades back, most of the organizations were only working with structured data sources. We used to extract this data from them using extract, transform and load or some kind of an ETL tool. So we used to clean and transform this data and load it back to data warehouse. So our data warehouse contains highly curated and structured data. From this data warehouse, it was used for self-service BI and for reporting purposes. While this system worked well earlier, but the problem is that now the data structured, basically the structured data only account for 20% of the organization's data. There is data available in variety of file formats like CSV, JSON and log files. We also have data in some audio and video format, and also we have streaming data as well. And this accounts for 80% of organizations' data today. So there has been an exponential growth not just in type of data sources but in data volumes as well. So to handle this, we also need to scale our infrastructure. While we may add more resources like CPU and RAM to our existing servers, it cannot be scaled up beyond a limit. And finally, data pipelines have to quickly adapt to support other use cases like machine learning and data sciences. So, ETL tools and relational databases were doing the job for us, and they still are, but to address the limitations in scalability, Google published a paper in 2004 on MapReduce and distributed file system. MapReduce is a distributed data processing technique, and distributed file system is a way of storing the data. Then, in 2006 came Hadoop. It is a framework that has implemented MapReduce concept for distributed data processing. And HDFS, as Hadoop Distributed File System, is a distributed storage. So let us deep dive more into this. Let's see what are the components of Hadoop. First, there is a storage layer called Hadoop Distributed File System. This layer has multiple disks, and the files that are stored here are in a distributed manner. What does this mean? This means if you have a large file, it will be splitted into multiple blocks, and the blocks will be placed into different disks. Okay? You can keep adding more hardware to virtually store unlimited data. So HDFS provides a scalable and fault-tolerant and low-cost solution to store the files. Then there is a MapReduce engine for data processing. It can process structured as well as unstructured data that is stored in HDFS. And this processing is done in parallel using multiple machines in Hadoop cluster. And finally, there is a cluster manager who is responsible for managing and allocating these resources required for processing this data. Here we have Yarn. So cluster manager or Yarn is responsible for allocating all the required resources for processing the data. So let's see how Hadoop works. Let's say we have some files which is stored in HDFS which is related to products. Okay. Now what we want to do is we want to filter this file based on active and inactive products. Also, we want to do some kind of an aggregations. Now, to process this data, we will first write the code that defines our MapReduce job. So once we have written the code for defining the MapReduce job, then the first job will be filtering those products which are active and inactive from the source file. Once it has done the filtering, it will store the intermittent file back to HDFS. Now, in order to perform the second task, which is an aggregation, there will be another MR job that will be reading this intermittent file and loading it back to the HDFS, which is the final output which we wanted. Okay. So if we carefully notice, each MapReduce job is reading and writing to the disk. This is what is known as disk-heavy architecture of Hadoop. So while Hadoop can process huge volume of data, there are certain challenges as well. So let us just see some of these Hadoop challenges. So the first one is to provision the infrastructure. So there are a lot of complexities in environment and setting up the infrastructure. Hadoop also has a diverse collection of open source projects, adding to the environmental complexities. Coming to the second point, since Hadoop has a low-level API, you might need to write a lot of code even for the basic operations. And as we just saw, it has a disk-heavy architecture, so these multiple input-output operations can significantly slow down the processing. Also, there is no built-in support for other use cases like structured data streaming and machine learning. Now, even though there are other open source projects for them, these further adds to this complexity. So, to address all of these limitations of Hadoop, came Apache Spark in 2009. Okay, so it used Hadoop MapReduce as the foundation, and it focused on improving performance and provide easy of use. So it is an memory engine to perform distributed data processing. So it uses its in memory to perform all of these required tasks. We will learn about it shortly. So what exactly is Apache Spark? So it is an extremely powerful analytics engine that can be used to perform large-scale data processing, be it structured, semi-structured, or unstructured data. Since it performs all operations in memory, it can run up to 100 times faster than Hadoop. We can get our work done by writing very less line of codes and the language of our choice. It has supports for multiple languages like Scala, Python, SQL, R, and Java. Also, it can be used in a variety of cases, be it batch processing, either it is stream processing, machine learning, advanced analytics. Now, we can install Spark on our machine or in an on-premise environment, but there are several cloud platforms built on Apache Spark, for example, Databricks, Azure Synapse, and Amazon EMR, all our Spark-based platforms. So in this course, we will see how to use Spark and use cloud-based services.